All right, guys, we're doing a video lesson today. This one is on, it's continuing with our systems of equations and inequalities, but we're starting part B now. And we are doing, today we are doing 5B.4, which is solving systems of inequalities. There's a couple of vocabulary words that you guys need to know on this one. So if you have your vocabulary sheet that you haven't quite finished yet, then you can pull that out really quick and do these. So we're going to talk about systems of inequalities and solution set first. So a system of inequalities is two or more linear inequalities that use the same variables. And we write them with one of these big S brackets, or I can't remember what they're called, sorry, but one of these big fancy little S ones, and we write them inside the bracket. We don't close the bracket over here, it's just one. And then we list them, and if there were more, then this would be bigger and there would be another one listed. But this one right here is a system of two linear inequalities. Okay? The solution set is a set of ordered pairs that make both inequalities true at the same time. The easiest way to determine the solution set is to graph each inequality in the system. So we're going to graph we're going to learn, so we already know how to graph linear inequalities. That's what we learned last time. But now what we're going to be doing is we're going to be graphing two of them on the same coordinate plane. And depending on where their shades interconnect, that's where the solutions will be. And you'll see that here in this example right here. So here's an example using the systems of equalities from above. So this one from up here is what we're going to use down here. So I'm actually going to, oh, never mind, I'm not. So make sure to follow these steps. So the first step is to rearrange, and that's the same first step that we had when we learned how to solve inequalities. And so the first step is to rearrange. We want to make sure both inequalities are in slope-intercept form, which means you need to solve for y. If you're still not sure, you really need to understand how to solve for y, you guys, because it is it's going to be the whole unit is just solving for y. And so you really, really have to get that done. My husband is texting me right now. So I'm trying to figure out why he's texting me. Sorry. Okay. So if you look here in this system inequality, you'll see that this one, our second one, is already solved for y. It already has y is greater than, and then our x, it's got our intercept and our y-intercept and our slope. This one, however, is not. This one is in standard form. So this one we need to solve for y. So that's why right here it says it needs to be rearranged. So we're going to solve this one for y. So the first thing we're going to do in this case is we're going to subtract 3x from both sides. This is a positive 3x, that's why I'm subtracting it. The only way I would add 3x here is if this was a negative 3 in front. But since it's not, I need to do the opposite, so I'm going to subtract. So we're going to subtract 3x, subtract 3x. When I say both sides, I mean of the inequality sign, okay? So 3x minus 3x leaves me with 0. I don't need to write that. So all I'm really left with on this side is 4y. Now that I'm just going to bring down my inequality so it's less than or equal to. And then remember, I cannot combine these. So it's got to be 12 minus 3x. Okay. Now I still don't have y all by itself, so this 4 is multiplying y, so I need to divide by 4. Okay, and I'm going to write that up here. So 4y divided by 4 leaves me with y. And I divided by a positive, so I don't change my inequality sign. 12 divided by 4 is 3. And then all I'm going to do here is I'm just going to pull this fraction out, make sure it's in its simplest form, and then I'm going to leave it. So negative 3 divided by 4 gives me a negative 3/4. Okay, I can't simplify that any. It's as simple as it gets, and then x. So now I have both of my, my inequalities in slope-intercept form or solve for y. I'm just going to rewrite it over here so that I have it. So here's the one I just did, and then this one was y is greater than 1/3 x minus 1. Okay, so we've rewritten them. They're both in our, what we call our system form, or we wrote it with the brackets. So now the next step, number 2, is to plot. And again, this is not nothing new for us. It's just that now we're plotting 2 of them on the same graph instead of just 1. So I'm going to plot this one up here first. So just off to the side right here, what I'm going to do is I'm going to make some notes for myself. So my y-intercept for this one is 3. And my slope is, I put an equal sign on one and a dot on the other, or colon on the other, -3/4. This one, my y-intercept is -1, and my slope is 1/3. Okay, so I'm going to be doing 2 lines now. I'm going to do 1 line at a time, and I'm going to do its shading before I do the next line, just so I don't confuse myself. And you're going to want, in fact, hold on one second. Okay, I had to go still. You're going to probably want 2 different colored pencils, highlighters or something. I would prefer pencils just because if you make a mistake, you can erase. But something that'll help you to determine where the colors cross over. Okay, so I'm going to do this one first. So my y-intercept is 3. So let me pull this up a little so you guys can see better. Okay, my y-intercept is 3, so I'm going to go up to 3. And then my slope is -3/4. So because it's negative, I'm going to go down and to the right, or I'm going to go up and to the left, or one of each. So I'm going to go down 3, 1, 2, 3, and over 4. 1, 2, 3, 4. Then I'm going to go up 3, 1, 2, 3, and over 4. 1, 2, 3, 4. Now, this line is solid because it's got the or equal to on it. So I'm going to get my ruler. Please make sure you're using rulers. And I'm going to make a solid line that goes all the way through my coordinate plane. Okay. Now I'm going to shade this one with my pinkish fuchsia magenta, pencil. And this is y is less than, so I'm going to shade below. It doesn't have to be perfect, but it should at least give you an idea. Okay, so there's that one. Now make sure you don't shade so dark that you can't see the lines anymore because you still have to graph your other one. Okay, so there's that one. Now I'm going to shade that. Now I'm going to do this one. I'm going to plot it and shade it. So this one, my y-intercept is -1. So remember, -1 goes down 1 on the y-axis right there. And then my slope is 1/3, a positive. So that means I go up and to the right. Up 1, 1, 2, 3. Up 1, 1, 2, 3. Okay. Now this one is just y is greater than. It's not an or equal to, so this one's going to be a dotted or a dashed line. So when I put my ruler here, I'm going to do dashes or dots. Dashes, I guess, makes more sense than dots, but so I've got these dashed lines all the way through my coordinate plane, just like that. Now this one says y is greater, so y is shade above the line. And then once you do that, you can start to see where the solution to this set is at. It's the shaded areas that cross each other. Okay, so all of these points right in here and on this line, not this line, but this line because it's or equal to, all of these, this area right here, and you can make it darker with another pencil or whatever you want to do, but it is all of this area right here. This is my solution to this system of equations. Any point in here, so like for example, I could pick this point right here, and this point is 1, 2, 3, 4. It's -4, and then 1, 2, 3, +3. I could substitute this point into both of these inequalities up here, and it would hold true. It would make it true. And that's how I know that it's a solution to both of them. This out here, this green part right here, this is only going to, like if I picked this point right here, this is only going to be a solution to the one I colored in green, which was this one. It would not hold true for the first one. It would only hold true for the second one. This one that's down here in this pink, like this point right here, this one is only true of the first one, not the second one. And these ones that are not colored in, this tiny little area right here, so like for example, this point right here, this one does not hold true for either of these. It's not a solution for either one of them. So this is a solution for both. This is a solution for, let's just say the second one right here. This is a solution for the first one. This is not a solution for either. Okay, that's the difference between all the colored areas. Okay. Next page. Okay, so now you guys have some independent work. This is work that you're going to do on your own. So this kind of refers back to the Clarita's pet sitting business that we talked about the last unit. It's got a system of equation here for you that we came up with the last one. And now it wants to know, it wants you to solve both of these for y and graph them on here and determine which combinations of cat and dogs works both for her budget and for her space. Okay, because if you guys remember, if you think back to our systems of equation, or the unit 5A.3 that you guys did with partners, this one right here talked about how much space she had, and with as much space as she had, she could have up to 15 dogs would fit. If she did no cats, she could do up to 15 dogs. But if you remember when it talked about her money, she could actually have 16 dogs, but her space won't allow her to have 16 dogs. So there's got to be an area, some solutions that fit both of these together, and that's what you're going to determine. You're going to determine which combinations fit both her money and her space constraints, okay? Then when you're done with that, you're going to list 5 points that satisfy both constraints. So these are going to be the points that are in the double shaded area. So you're going to graph it, you're going to shade it, and you're going to list actually 5 points, 5 points in ordered pair form that fall in the shaded area, any 5 points. So then you're going to list, after that, you're going to list 5 points that only satisfy one but not both. So, sorry. Like for example, in our example here, this area, the only pink shaded and the only green shaded, those are ones that satisfy one constraint but not both. Okay, so that's what you'll do there. And then you are going to be done. And then you'll have some homework. Okay, so when you're done with this, bring this and your notes up to me so I can check them off. And then I will give you, with your stamp sheet, and then I will give you the assignment sheet, which I'm not 100% sure. Hold on. That paper right there. It's actually a coloring activity, so you'll get to color some more. All right, so I will see you guys later then. Thanks, bye.